Hi guys, it's Dido again. Uh, Welcome to another episode in the Breakout series. In this episode, I'd like to generate layouts for our bricks. So we have our different compositions, and I want to do this based on some configuration in a file. So I'll use a text file which will contain only zeros and 0 1 2 3 and basically will contain numbers, and those numbers will translate to different kind of bricks that will initialize on the field. So let me give you an example. I have prepared one scheme here. So imagine that we have this data, and we have rows, and each row is represented by zeros, 1 2 or 3. So every number represents different kind of brick. So when we have a 0, we are basically not rendering any brick. In the case where we have 1, we are rendering a basic brick, and so on. When we have 2, we are rendering a brick with 2 hit points, and its graphic is a little bit different. For example, it have this little border that represents that the brick is stronger, and this is also applies for number of 3. So let's see another example how this is actually represented in the game. Imagine we have this file, text file, that is containing only those numbers. So in the first row we have 0 0 2 0 0, which is like imagine that here we have a brick. So we have nothing, then we have a brick of type 2, then nothing, and then nothing again. So, and on the second row we have nothing, then brick of type 1, then brick with hit points 3, and then brick with hit points 1, and then again nothing. So, and this also for the other rows. So this is the idea behind it, and just wanted to explain you this before we start doing it. So yeah, that's it. All right, let's get straight into Unity and do this. Okay, so the first thing that I would like to do is to read the data for our levels from a text file. So yeah, and now let's create a variable, actually a property that will store our levels data, and it will be of type list, and list of matrices. I mean list of integer matrices. So yeah, let's call it levels data, and set its properties. I mean set its getter and setter. So okay, once we are done with this, on the initialization of the bricks manager, we will load the data from a file and populate this field. So this property will be used later on to render the data. Okay, great. Now it looks like I have some typo, but yeah, this coming from this semicolon. I'll just delete them, and hopefully this works. Okay, once the code is compiled, I will create this folder called resources. So here the name resources is important because Unity is looking for folder with this name, so it can read dynamically files while the game is running. So here I will create this text file called levels. And in it I will basically populate them the same way that I described you previously. We'll have these rows with numbers, so each number represents a brick or an empty space. So zeros are empty space, 1 is a brick with 1 hit points, and so on. But yeah, here I will basically copy paste my the grid that I have used previously when I did initially the project. And but you can create your own, it's not that hard. And as you can see, I have those dashed lines, so those dashed lines represents the end of the level, so it's important to have them so our code knows when the level is ending. Okay, once we have the file, let's go back to Visual Studio and read the file, parse the data and populate the property in it. So how do we do this? We do this by using Unity's method resources WOD. So here this method wants one argument, which is the name of the file, and our file is called levels. So by doing this we get the data from the file, and now once we have all the data we want to split it into rows. So first thing we'll do is to split the whole text into rows, and we do this by splitting by environment new line. So this will give us a array of all the rows from the file. Okay, next thing we will do is to create a temporary variable that will store all our levels data, which we will use later on to assign to be returned. So we need another variable which will store the current parsed level, which will be of type int matrix, multidimensional array. And when we are doing a multidimensional arrays, we need to provide the dimensions. So the dimensions are the maximum rows and maximum columns that you can have in the game. So I have done a couple of tests, and yeah, we can have a maximum of 17 rows and a maximum of 20 columns. So that will do. Okay, great. So after we have those variables, I'll introduce one more, which is the current row, and start iterating over the rows. So we do this by creating a for loop and iterate to every row. Okay, I'll create a new variable called line, which is basically a row. So once we have the line, we will iterate by each character of the line. So this is like, you know, each 0, comma and so on. So here, first thing I'll do is to check whether or not the line contains those dash lines. So if it's not containing the dash lines, I will execute the logic of parsing. But if it is containing the dash lines, this means that we are done with parsing the current level, and we will have to store the parsed information in our collection of levels. Oh. Okay, now let's go into the case where we are parsing an actual row. So we want to have a collection of all the bricks, which are basically the numbers, and we are doing this by splitting the line by comma. So when we split the line by commas, this will give us a collection of all the bricks in this line. And now I'll iterate once more to all the bricks. And once I'm doing this, I will basically, once I get the number, once I get the brick, I will parse the value and assign it to the current level. So you see, I'm reading the value, parsing it to make it an integer, and assigning it to the current level. And when I'm done processing this line or this row, I increment to go to the next row. Okay, and here in the else statement, once we know that we are done with this level, it is important to reset the current row and add the current level to the whole levels data, and also reset the variable current level to be again empty. So in the next iteration we will start from scratch. Okay, and at the end we just return the levels data. So basically this whole method reads the file, parses the information, and creates this object that is a list of matrices. And later on we can use this property to render the actual bricks in our game. So now we cannot see anything in Unity, but to check this we can debug. So I'll attach to Unity and start the game, and we can see in the inspector that everything is parsed as we expected. So we have like 4 levels, which is we had 4 levels in our file, and as you can see we have zeros, ones, and so on where it's needed. But yeah, here it's hard to imagine what's going on, but yeah, once we render them it will be easier for you to understand what's the idea behind this. Okay, great. Now let's start work on the actual rendering. So now we will read this data that we parsed previously and instantiate the bricks. So okay, first thing that I'll do is to create a new game object which will hold all the instantiated bricks. So this game object is not existing before that. We will just create it out of nothing. So here I'll create a new variable brick container, and this brick container will be equal to new game object with the name of bricks container. So next thing that I'll do is to create a variable which will store all active bricks. I'll call this variable remaining bricks, and yeah, in the start method I will set it to be equal to new list, so we don't get exceptions while we start the game. Okay, great. Now let's create a method called generate bricks, and press Ctrl dot to create the method. And here we're gonna have to use the data that we parsed previously, the levels data, to instantiate the bricks. So first thing we will do is to get the current level that I want to use. So I'll create a variable called of type int matrix, which will be current level data, and it will be equal to this levels data with index of current level. But since we don't have this variable yet, I'll introduce it now and make it to be not a property but a field, public field, so we can modify it in Unity if we want to change the level. Okay, once we have this, so we have the current level, we need to iterate over it and instantiate bricks. So first we need the coordinates for the spawning, and we need the spawn x and spawn y, but since we don't know where to start, we want to have initial position. So I'll introduce 2 new variables. One is initial brick spawn position x and initial brick spawn position y, and those positions will be basically hard-coded value for the positions of the first brick, and that's like top left position somewhere. So the values there are for the x value is -1.96, and for the y value is, what was it, 3.325. So this is like the initial position of the first brick, and once we have that, for each other brick we will increment this value. Okay, now let's introduce also one additional variable which is called z-shift. Z-shift will be used to make each new brick a little closer to the camera, so they are not like overlapping. It's like a little trick. So now I'll create 2 for loops. The first one will iterate over the rows, and the second one will iterate over the columns. And here I'll get the brick. So from the current level, I'll read the brick, and I'll decide what to do based on its value. So if the value is more than 0, which means it means that we have actual brick. So here we will need to instantiate a brick. So I'll create a new brick and call unity's instantiate method, and here I'll need a brick prefab, but I don't have yet one, so I'll have to create a new public field which is called brick prefab of type brick. Okay, and now let's comment out and assign the prefab so we don't forget. I like to assign them as soon as I introduce, because I forget later on. And now I'll create a prefab out of this brick, because yeah, we didn't do this yet. So I'll drag the brick, and yeah, once we have the prefab, I'll assign it to our bricks manager. So we have the prefab of the brick, and I'll again uncomment this. So we have the prefab. Now we need to set the initialization position. So it will be, the x value will be current x, and the y value will be the current spawn y, and for the z value it will be basically 0 minus this shift that I'll be incrementing on each iteration. For the rotation, as always, quaternion identity, and then we cast the brick, the object as a brick. And here I'll create a new method which currently doesn't exist. It's called init, and this will be used basically to set up the brick once it's instantiated. And the first, I'll pass a couple of properties that it needs. So first is bricks, the container. Then I'll pass the sprite of the brick. So the sprite will be based on the type. So, and the next thing is the brick color. So, but to have the brick color, I'll introduce a new public field of type color, and here we'll set in the editor what type of colors we can have. But here the color is also defined based on the hit points of the brick. So for each hit point we have different color, and the last thing that I'll pass is the actual type of the brick and the hit points. Okay, let's implement this method. I mean, just create it with control.enter, and here I'll leave a comment so we later on return here. Now let's imagine that this is working. We just continue with this method, and then we'll come back. Okay, once we have the brick, I'll add it in the remaining bricks collection. So the remaining bricks collection contains all the instantiated bricks. And important thing is to also increment this z shift by just a little. So, you know, this trick that they are not overlapping. Okay, once we spawn a brick, each time we spawn a brick, we need to shift the x value a little. So here I'm introducing again a new variable called shift amount, which will be basically the value. The shift amount is basically equal to the width of the brick plus some minor gap between the bricks. And by doing this, we are shifting the position for the next iteration. So in the next iteration, we will, you know, spawn a brick in another position. And here we have to do a check whether we have reached the end of the columns. So once we have reached the end of the columns, it means that in the next iteration we will have to start again from the initial spawn position. So okay, and here once we are done with the row, we need to do this shift again, but this time with the Y position. So every time we finish a row, we increment the Y position. And last thing is to introduce a new variable that will be used later on, which is called initial bricks count, and this is equal to remaining bricks count. So this variable will track what is the initial count of the bricks for the current level. So good. Now we're done with this. Except, yeah, we need to configure the colors. So I'll create 4 colors, which basically the first one will be not used. So, and yeah, I'll set for all of them the color to be this blue color. Yeah, okay, great. Now once we have the colors, I will go and implement this method that I told you. So here, once we've created the brick, we need to set a couple of things. The first one is to set the parent of the brick to be this container. So yeah, they're like this way they will be like grouped. Also, so I'll change the container to be this new object that we created, and here I want to assign the sprite, but so we need a sprite renderer of the brick, but since I think we already have them, so we'll just use the reference that we already have, not get a new one. So I'll use sprite renderer sprite and assign the sprite, and now I'll also assign the color of the sprite to be equal to the color that I'm passing, and also assign the hit points. Okay, great. Let's save this and see if there is anything else. Yeah, I'll have to delete this line because we no longer need it, and this sprite renderer reference, yeah, I'll put it in awake method. Basically all the references, it's good to be in the awake method. So one more thing that I forgot that Unity makes sometimes is that when you create a color, it basically creates it with the default value. The alpha value is like 0, and this makes the color transparent, and basically this will make our bricks invisible. So let's now test this, and yeah, we have bricks. So our logic is working, and based on our configuration we are spawning different things. So let's change the level. So I'll change the level, and as you can see we have different configuration, which is quite nice. Yeah, and test it out. Yeah, the destruction is also working. We can blast things around, and yeah, that's quite nice. Okay, great. Now let's test if the logic is working for the other type of bricks, because currently those levels are only with 1 hit point. So I want to vote the level which contains bricks with more hit points, which should be number 2, because we start counting from 0. So yeah, as you can see, this is also working. We have pretty nice bricks with different colors, and once we collide with them they change their sprite and all that. But let's now test if the colors is working. So I'll make the harder bricks to destroy, for example red, and those with 2 hit points, those with 1 hit points can be yellow, and those with 2 hit points can be probably orange. So if we start now, yeah, we also have colors, which is pretty cool. And yeah, if we test also the particles is working, and if we destroy a red brick, the particles will be red, and if we destroy yellow, they will be yellow. I think this is quite nice. Yeah, maybe here we can make the color change also when we change the sprite. Not sure. This also looks nice. And yeah, we have levels. So now let's save the code, and yeah, we will be done for this episode, guys. So this is yeah, the easiest part. Let's close the project and go into its folder, and here open git bash, and after this we check the status by typing git status. We have a couple of new files. Let's add them. So here I'm checking the works, nothing important, but I'm adding by typing git add dot, and then let's commit. So git commit, and okay, let me think of name. So we added okay, so basically reading and generating levels from file. Okay, that's good of a name. Let's press enter. So we created the commit, and now I'll push the commit to GitHub. Okay, git push origin master. This will push the code to GitHub and everything will be saved. Okay, nice. This is pretty good so far. I'm actually not quite sure about the next episode, what to be, but I think we can work on actually changing levels when we complete the level, or and also maybe working on the start game and end game mechanic, and you know, the death screen when you die. I think this will be good for the next episode, and once we are done with this, we'll basically have like the whole game working, but without the special effects, and maybe I can leave the special effects for like bonus after that. I'll definitely do them, but just, you know, to make the whole game complete before starting working on that. So yeah, okay guys, hope you enjoyed this episode, and yeah, if you like it, please, you know, like, share, comment, and so see you guys in next episode. Cheers.